directly. And that's what makes this demonstration work, because we're using Protege. We don't have any software between FHIR and what's going on, so we don't have anywhere we can write code that says this is how we interpret this. And same for the rendering, the resource types. The fact that somebody has graciously discovered both how to construct this URI, which isn't obvious, and we don't have software to do that, where we're just using off-the-shelf tools. And the fact that if we know what its type is, it makes it extra handy for us, especially if we can't dereference what this points at. Here it says patient, so you can say, well, it's obviously a patient, but we get all sorts of interesting ones that are very deliberately put into the example set that from the value you have no clue what they're referencing. And yet if we're going to reason about patients with particular diagnoses, it's not going to do us much good if we decide that this device is sick. The ontology header, the other bit we talked about again, which is, in the end, it's a way we have, the reasoner says you have to have fhir.ttl. That means you got to import it. There's no RDF import. That means you have to have an ontology header. And thus, the primary reason for these two lines, the version URI, I had wrestled with the fact when we were constructing this that we were doing everything on the FHIR build site. But as soon as I crossed my eyes, I ended up on the FHIR STU site at the time that didn't know squat about RDF. And so I used the version URI to keep myself on the same dang site. In hindsight, it turns out that that problem isn't unique to RDF. You hit it no matter what you're doing. You keep finding yourself on the ho7.org rather than build.fhir.org. As such,
as long as you didn't go back the other way by accident.
That would, yeah. But what I'm going to propose here is just tying this into the FHIR versioning scheme. If we actually have a version identifier in the meta, go ahead and put this in here. If we don't, just stop it. And just agree to the fact that now at least there's RDF on ho7.org, so you don't completely crash. Okay, so what we're talking about is using FHIR RDF with a description logic reasoner. The task I've set out to do, so I've got an instance of a diagnostic report that I'm going to pull off of a FHIR server. And the question I put together, it's just a sample for playing with, is this a diagnosis of cancer? Does this contain, and this actually turns out to be terribly useful because, at Mayo at least, we're always interested, patients come in, they have their tests done, and 24 hours later they leave. And we have all these studies going on, and if they're a candidate for some sort of study or some sort of protocol, we really want to catch them right while they're there, sit them down and say, look, we just discovered that you were diagnosed with this cancer or this particular disease. Would you be interested in enrolling in this study? And if we wait until they leave Mayo, it gets a good deal more complicated. So one of the things we really want to be able to do is just put listeners on data moving into the Mayo system. So this is a listener I just want to put together. It says, does this have a cancer diagnosis in it? So start out there. This is the easy part. We have FHIR Resource instances. In the last talk, we at a high rate of speed showed how to access them off of the FHIR website. The other bits we need to get this done, we need the instance descriptions. This is what motivated the presence of fhir.ttl as it exists today. We need to know which things in here are object predicates, which of these are data, object properties, data properties, annotations, which are classes, etc. We need to know, we need a description of what's in this fhir.ttl, so that's the instance descriptions. I've got a classification rule that says malignant neoplasm, but somewhere I need a bit of domain knowledge that tells me, how do I know whether something's a malignant neoplasm? Because you're rarely diagnosed with cancer. That's kind of the equivalent of being prescribed a drug. You're usually prescribed a particular drug. So this is the FHIR Resource instance. This is the URL, what we've got here, and I put in the bits we're working with. We've got the subject, the code. Well, let's see. This is the diagnosis. It's a CT scan, but the coded diagnosis, which is a malignant tumor of the craniopharyngeal duct, which, if you're an MD, you'll know as a cancer, maybe from malignant tumor, but a computer has no idea what that is. That's the SNOMED code for it. I mentioned the metadata vocabulary or URI catalog or whatever we're going to do. I can take FHIR diagnostic report and discover that this in our world is now class. The diagnostic code is an object property, as with coded diagnosis, and the FHIR value at the moment, because of the way we're doing things, is the data type property. That's what the reasoner needs to know. Okay, the next, so we've got FHIR.ttl, we've got that satisfied. We need the domain knowledge. Well, we've got SNOMED CT, and you can pull SNOMED CT into Protege, and this is an example of it here. And you can look up the particular code that's in the FHIR thing, which is the malignant neoplasm of the craniopharyngeal duct. And if you follow it up its inheritance tree, actually, I have to follow a bit further, but eventually we discovered that it's a malignant neoplasm, way up the reasoner there. So I've got that bit of knowledge. And we have SNOMED, but I want to mention you can have other ontologies. There's, it's not just SNOMED that's knowledge about a domain. There's other domains that have great knowledge in them, especially if you get into the biomedical or the bio area, the OWL Ontologies, the phenotype ontologies, etc. And also in a minute, we'll talk about why we want the FHIR coding systems in there. Okay, the final thing is the classification rules. And I've written this in OWL functional syntax. It's not the most legible thing, but it's more legible than some OWL syntaxes. And what I've done, well, one thing I've done that for convenience, and we may end up wanting to put this as part of the FHIR Metadata Vocabulary, is I've declared a diagnostic report coded diagnosis coding predicate. And I've just declared it inside here, and I've said it's a property chain. So if you go to the coded diagnosis, and then you follow the coding inside the coded diagnosis, it's the same as this. So it's a way of gluing, when we're crossing those little B nodes that we showed in the last session, it's the way of putting them together. And I'm thinking we probably want a set of those in FHIR.ttl so that everybody uses the same names instead of having to give them their own names, and object property chains are not the easiest thing in the world to understand anyway. But what I've done then is I've said, okay, I've got a report with a cancer diagnosis, and it's equivalent to any diagnostic report that is an instance of malignant neoplasm. So, yeah. And okay, this is the one here. So this is the malignant neoplastic disease I've got here. I just showed I pulled that in here. Now, somewhere I've got the URL out there, or you'll see it again. But this is actually all tremor force. Oh, wake up. Oh, good. Okay. But you'll find cancerreport.owl. There's a GitHub site out here that has everything you need to make this run and all the instructions on how to do it. And you can pull that in and reach the conclusions. So I've done a git clone of that site here. Well, ignore the iCloud keychain. I'm not even sure how to get to it. It's on the screen. Hopefully it doesn't get in the way too much. Cancerreport.owl. Oh, right, and there's the URL. Good. So the Yosemite talk, which is one we did earlier, there's the particular one in here. Run the reasoner. You'll note I'm running fact++, and for those of you that know about reasoners, Fact++ doesn't, it can process SNOMED, but it takes it a long dang time to do it. So one of the things we've done for the purposes of this demonstration is we've filtered out subsets of SNOMED. We've got a little tool that if you give it a list of concept codes, it will give you the ancestor and descendants and neighbors enough so that you have everything you need to reason about that particular code or set of codes. The issue that the ones of choice, being a snow rocket or elk, don't deal with A boxes. They know nothing about individuals, and they've got a couple other issues. Something that before we can use this move from annoyance to anger, we're going to have to resolve. And there's some other possible ways to do it. Pre-classifying SNOMED, because we're never changing, we're just putting in individuals, we're never changing the rules in SNOMED itself. But anyway, I pull that in, I run the reasoner, and well, here it's kind of underwhelming. Nonetheless, I pulled in a particular diagnostic report, and I discovered, yes, it has cancer diagnosis. Now, Lloyd said, well, that's good, but, well, the first thing, actually I've got it in the other order, so the first thing is I did mention the devices here. And actually, if I'm going to have this and it's going to be meaningful, I can't be having devices with cancer diagnosis. So this is just another example here where I've said, okay, this is a diagnostic report with a subject patient. So I can add that in and use that as a rule that says only reports that are about patients. And this is the one that Lloyd said. He said, well, you don't want preliminary reports coming through there. You may be real interested in just final reports. So one way to do that is that I went out to the diagnostic report status and found this is the value set and code system for the diagnostic report status. And I said, well, final, I mean, they have a code of final, but if it's amended and corrected, that seems like a good idea too. So I made some arbitrary decisions as a programmer, and it's always bad when you let programmers make decisions. Because even if they do get it right, which isn't very often, it's documented in code, and so repeating what they do doesn't work. But I went out and I said, okay, I'm going to go down here and I'm going to use a data, some values from, and I'm just going to put in all of the codes here. And that did work, but brittle. I've taken a hierarchy, I've created flattened strings. We don't know that this is being used. If somebody adds another property to amended, we don't know that's happened. If they fix it and really come up with, et cetera, there's reasons that embedding text into a rule, and there's the complexity issue as well. So what I've done, and we're going to get this generalized, is I went out there and took the diagnostic status code system and turned it into a little OWL ontology.
Wait, haven't we already done that?
Well,
oh, that's what you took out, right?
Well, no, this, you had it in, but it wasn't an OWL ontology there.
Yeah.
We'll get it.
Okay. Right.
I guess it was close,
Yeah.
Well, we want it to be there.
but we wanted to be there.
Yeah.
And so, yeah, it's getting these resolved. So we have it back in here. And so what we're looking for is OWL representation of all the code systems. Yeah. Then I can just, then we generate the URI, which is the report status final that represents that. So that's another bit that we've got here. And finally, I can write a rule now that says a final patient report with cancer diagnosis, which is then any diagnosis that is a patient report, object intersection says and, is a report with cancer diagnosis and is final. Again, there's the link to it. And we run the reasoner, and if we go to final report, we find out indeed this is. While we don't have anything extensive on the website, we've also gone through with some testing to make sure that it rejects things that aren't. That's interesting, but if you look at it, there's other ways to solve that. You can take the hierarchy of cancer diagnoses, and you can compute an SQL table that's really quite approachable, that, an ancestor table. You don't have to use a reasoner to do that. But let's take a more interesting example here. And this is a post-coordinated expression. This isn't in the examples, I wrote this one up. I said, okay, I'm gonna put together a malignant tumor with a finding site at the left lobe of the thyroid gland. This is the coordinated expression that you can put in the code. The OWL, or the RDF generator at the moment, doesn't build this bit. This is something we need to do, but this is an OWL expression that represents what this says. And we need to work with geniuses like Michael Lawley to generate this, to call their server with this expression to get this fragment here. But this is actually an OWL statement that says it's a restriction on a role group property, which you really don't want to know about, but you have to know about anyway if you're going to use SNOMED.
Yeah.
And it says inside the role group, it's finding a restriction on finding site left lobe of the thyroid gland. Now the classification is pretty simple. What I'm interested in here is I want a report of any thyroid disease. Now note, I have a very specific disease, which is malignant neoplasm, and I have a very specific location, which is the left lobe of the thyroid gland. Those are not easy to generate in an SQL table, and those are why reasoners exist. Because I have to know that the left lobe of the thyroid gland, a disease of the left lobe of the thyroid gland is a disease of the thyroid gland, and that a malignant neoplasm is a disease. And so I put this in, we run it through the classifier, and it works. Now I've done it. Okay. It's just going to come back anyway. It's going to demand it, isn't it?
Yeah.
Okay. It wants to use the keychain and it won't take no for an answer. Okay, a second, and where are we on time? 45, so I think I have about 10 minutes, okay. A second thing that we've been doing is getting the on idiom has all been used up, so I tried a new one here. I've got FHIR in I2, B2, so it's I2, FHIR, B2, that's FHIR in I2, B2. And the general idea is seeing how we can use FHIR in this toolkit. It's a relatively mature toolkit called I2B2. It's used by researchers to gather together data and do research studies. It's in the core of it, it has an observation fact table, and that's interesting because it's a very primitive structure. What you've got basically is a key that consists of an encounter, a provider, a date, a concept code, and an optional modifier code. That's not obvious here. But these things then give you a clump of data. And the data can be numeric or ASCII, it have quantity, units. It should look familiar to anybody that's messed around with data types. They've just kind of clumped it all together in here. So the general idea is given something that identifies a patient in the counter, in either one or two concept codes, get some data out of it. And then the way they deal with it is they have an ontology table. And this gives the researcher a list of all sorts of things they can select from and drag over to a little query building tool with ands and ors and what have you. And when you drag things over, each node generates a little SQL snippet. And when I say amongst other things, you can also use it to select types of patient and things. But what we're interested in is it's an SQL query that gives us a set of concept codes and optional modifier codes that allow us to select rows in the observation fact table. That's how it works under the covers. So, what we're doing And I don't remember, later in the slides I probably talk about the justification, but I'm going to talk about that for a minute here just in case. Right now at Mayo, we have two groups working away rather tenaciously. We have a warehouse, universal data, UDR, DP, what have you. And one group is working very hard to transform the contents of that into FHIR so that we can share it and access it from FHIR. We have another group that's working very hard to transform that data into I2B2 because they're starting to come up with a relatively standard catalog, or they're thinking about it anyway. And it occurred to us that it would be really nice if instead of having two groups converting the same data into two different models, maybe we could just combine it into one. And that's what we're playing with here. So what we've got, what we're playing with is we take the fhir.ttl, the catalog, and we can turn it into an I2B2 ontology that gives us a list, the name of and a list, and it just uses the concept codes that are right inside fhir.ttl. I'll show you in a second, in the ontology cell. And then we can take another tool that takes a set of FHIR Resource instances in the RDF, so we have the codes, and it loads it into the observation fact table and, when necessary, bits into the patient dimension table. As I show here, generate I2B2 is the tool that does this right now, load facts does this, and we do have this JSON RDF library, which we run over either large queries so you can pull huge amounts of data in or test data or what have you here. URLs there.
So you're not using a server that does RDF itself?
We would like to, but the big collections of data that we need are out on the Smart on FHIR and Cynthia, and they're sample data. Basically, it's there because RDF hasn't permeated the FHIR infrastructure enough, and we want to be able to use this now. So, yeah, the way it works is the client navigates the ontology cell, finds the things they're interested in. I want hematocrit results, I want patients who are diagnosed with particular diseases, etc. The client formats a query. This goes to the CRC cell. The query goes over the observation fact table and gives back the client a set of matching patients. So, the ontology cell, I've just taken, let's see, and this also shows some of the issues we're going to have to fix, but I've taken value codable concept down here, and these are various entries in the hierarchy, which you'll see on the screen in a minute. This is the concept code, which is taken right off of there, the value codable concept, and then at the moment, well, we've got the coding, and then we have a code display system, etc. One of the things that we do need to do is collapse the FHIR data types into the I2B2 data types, but for this first approximation, we are just taking FHIR.ttl literally and putting it into the navigation cell. So, if you look at, this is the FHIR structure definition for observation, and at the moment, if you're navigating it in our I2B2 thing, you come down under clinical diagnostics, you've got observation, and then here's all the things that are in observation, and way down at the bottom here, I've got codable concept coding, just as an example here. This is obviously not what a researcher wants to do. And a researcher should not have intimate knowledge of the FHIR observation resource. But being able to do this and make it work is the first step. Then we can reorganize this catalog in ways that are much more interesting, depending perhaps on some work that Graham's been talking about doing in the W5 ontology, but we'll see where we go. Okay, so this is an entry in the observation fact table, so a set of concept codes over here. This one actually goes down to the component level, so we've got concepts for the resource ID, the coding, category component, etc. We've got modifier codes where appropriate. Again, these should look familiar. These are just FHIR URIs. And then we have associated data. I kind of chopped it off here, but here's a code for a blood pressure, I think is what's going on there. Apologies for chopping. But this is what it looks like in the observation fact table. And now what I've done here is I've gone over and I've dragged an observation code, coding code. And again, not something a researcher wants to do, but we can give these different names and we can make them much more useful. But the key is I can pull it down. I can say I want link.org. I don't remember what this was for now. This is blood workup or a liver workup or something.
Yeah.
And I've said I wanted a value greater than 100. And I hit run query, and it took a couple of seconds, and it says, you've got 163 patients out there that have a liver function, whatever it is, greater than 100. So, just a real short nutshell, it's here. We're going to be working with the I2B2 community, but it's our hope that having FHIR as the basis for the observation fact table, we can begin to exchange I2B2 data amongst researchers. We can load it automatically versus having to have a team of people trying to load this particular stuff for particular researchers. And we can organize the ontology table to meet individual researchers' needs. So, right, we've proven it can work. We've got a lot of work to do, but so far we haven't hit anything that counts as a showstopper. It looks like the rest of it is very doable. We're pretty excited about where that's going to come out. And we have a couple minutes. FHIR.schema.org. Okay, we have this URI catalog, and earlier we touched briefly on schema.org where we had a birth date URI that I was showing in the previous talk. Okay, what schema.org is all about is it's a catalog of URIs. Now, the domain of schema.org originally was people that sold stuff on the web. Google wanted to be able to be really clever as far as running queries. I'm interested in watches. Then it wanted to say, oh, well, you know, Macy's sells watches, and Sears sells watches, and Sears used to sell watches, et cetera, et cetera. And so they came up with this catalog of things that has to do with what you sell. And they said, if you'll go into your HTML and either use a notation called RDFA, it's the microdata, or JSON-LD, if you put that into your web pages, why, we'll find it, and it references schema.org. We'll use it to be more clever. So when you start looking for watches, you get this thing up on Google now over here, and it's a nice little catalog of watches. And what it's done is they've gone down and scraped all these sites, and they found all this information. Not just they sell watches, but how much they sell it for, and other details. And they're actually very indirectly pulling RDF data out of all those sites. RDFA is a way of adding RDF to HTML. And so that gets us over here. Another group, healthlifescience.schema.org, has come out with a set of URIs, a proposed set of URIs for talking about the healthcare domain. Now, this isn't talking about healthcare records. This is talking about patients and doctors and diseases and what have you. Medical condition being an example here. And they've published it just like schema.org, and in fact, it's sanctioned as an extension to schema.org. And what's interesting is that if you go to a site like, this is John Hopkins, I think. Unfortunately, Mayo's starting to do this, but Cleveland Clinic has the best example right now. If you go to their HTML, you'll find this stuff in here where they've got references to schema.org medical stuff. And furthermore, if I ask about anemia in Google, I get this pop-up over here that talks, oh, this is all about anemia, and by the way, if you want to know more about it, you can go talk to the Cleveland Clinic. So, sort of, kind of combining medical knowledge and maybe marketing. I don't think they really understand their position there yet, but nonetheless, the organizations are doing this. So, can we use the FHIR.schema.org in the same way for clinical research data, basically? We've generated a FHIR.schema.org. It isn't up at the moment. There's, like the next, oh right, somewhere there I've got a URL for where it was. I got tired of paying for the website, and we're going to get that fixed, though. I found somebody that was in the room that will help us put that back up to play with it. But the idea is that we've got all these URIs, and we can go out to somebody's blog post, and they say, I'm worried that I have anemia. Well, maybe we can mark that up. We can annotate that with, patient reported symptom of anemia. I'm taking such a drug. Well, the FHIR medical code for drug my ID is. Or another place is the PDAs and those sorts of things, the heart rate monitors, the glucose monitors, all that sort of stuff. Can we mark up, I mean, ideally, it would be great to have them pumping FHIR out, but if they don't, can we mark up the XML with FHIR tags so that we can fairly easily convert this into a FHIR resource? I'm sure this is terribly important, but just an example of an embedded RDFA in here. Right. Okay, one obvious place, and whether we use FHIR.schema.org doesn't really matter, we've got the FHIR narrative text, and if you go in there right now, you've got little blocks of strings that said, oh, by the way, we pulled this out of FHIR field such and such. Using the URIs, we can actually mark up the HTML so that we know exactly where it was derived from, and the narrative text potentially could produce the same or a subset of the RDF, the data data. An extension of that would be an HTML FHIR interchange format, PDA I mentioned, CCDA, another way of doing that using RDFA. I mentioned blogs and another things like that. Just things to play with, ideas. Now, what's interesting about this is, as I was talking to Graham a minute ago, as I was thinking to myself this morning, one of the things that we really want to have happen is I want the observation.status URI, if you put it into a browser, to have the FHIR organization, HSM organization, say, yeah, that is the URI we use. Return some sort of friendly 200 or a redirect or something that allows us to verify that, yes, that's right, and this is what it means. Well, if we do that, we're already halfway towards FHIR.schema.org. And if we're careful, if we do the markup in a way that the Google browsers and everybody, if we document it in a way that the Google browsers and everybody else wants, we may not need a separate site. We can just use ho7.org/FHIR/ something. Or we'll have, it can't be / something, but.
So at the moment, if you enter a canonical URL into the website, if it's a published canonical URL, not a build-only canonical URL, you'll get redirected. And the redirect depends on your accept media type. If your accept media type has got JSON in it, or it's got XML in it, you'll get redirected to a file which returns you the appropriate.
I mean, if I put in observation.
So that's not a canonical URL.
Okay, so the definition of this works. In fact, my guess is that my media type at the moment is turtle.
So your media type is HTML.
Okay, I
So
don't.
you're redirected to the HTML version.
Right. I thought I'd put in a turtle in there, but
But I don't, in the redirection code, I don't look for the underscore format parameter.
right.
So I have to do that.
Now,
And also, I only do canonical URLs. I don't do those URLs. I
Yeah.
haven't generated them.
and
I can, it's just another 100,000 files, what the heck.
well, maybe we can help with that. And the other bit about that I think will be very useful is schema.org has certain requirements. Maybe we can come up with, we can look at their MIME type versus ours and see whether there's a way that we can simultaneously serve stuff up in the format that the Googles of the world want. We'll play with it and see, but that's another possible use anyway. So in summary here, I've talked about three different things that we've been playing with, or it's more than playing with, seriously trying to get work that use the RDF implementations of FHIR. And the presence of the RDF catalog, while preliminary, is very exciting because I put in a paper about the SNOMED work, and one of the reviewers said, well, this is nothing new. We've taken CDA and we've taken HL7v2 and we've turned it into RDF and we've run it against reasoners. What's so big about this? So, well, yeah, but you've generated your own URIs. Nobody else is going to use them, and you've generated something that works, but you can't just go out to a CDA server and pull that off, or you can't have somebody write a set of rules. You got to agree on the URLs you're going to use, and that's what the FHIR URL catalog, metadata vocabulary, ontology, whatever it is, it becomes the Dublin core of healthcare.
So I have a question for you, Harold.
Mm-hmm.
You might get upset by this question, but I could do all of that you did in a simple FHIR search and get the answer instantly.
Mm-hmm.
If the service supports a value set based query, am I wrong or right about that?
You're wrong, I think. You could do everything I did except the query on the disease of the thyroid.
Why couldn't I do that?
Because you need to understand that a malignant tumor that has a finding site of left lobe of thyroid is in fact a disease of the thyroid, and SNOMED doesn't have any code for a tumor located in the left lobe of the thyroid.
So you were post coordinated in SNOMED?
Yeah.
So I could still do it, right?
If you call it a reason.
Well, that terminology service performs that role, and so if you can do this right now on my server, you can post the values that describes the relationships you want.
Cool.
You can post the observations as a post-coordinated SNOMED concepts, and you can bing and do the search.
All right.
And have I missed something here?
I don't know. Somebody's missing something.
What we can say
because,
for sure is you can't do that in the commercial EHR servers.
yeah, that's true.
Mine's the only server that strung all that together, but the idea of the terminology servers is to make that easy to do.
Yeah. And I guess I would see. I know how to take Protege Day, and I know how to load all sorts of interesting ontologies in it, and I've got a set of rules for describing classes. And you may have those same things in your server, but I don't know how to use it at the moment, and there's not many people that do, but that's fixable. Right, that's fixable.
Yeah.
But B, it addresses the FHIR SNOMED problem. What happens, for instance, if I go ahead and say, well, I'm interested in the phenotype ontology. I actually care about that. And I'm going to use FHIR and put some codes for the phenotype ontology in there. Or,
So we're talking Joel Snyder's non-coding systems?
well, I guess we're talking generic RDF and reasoners versus FHIR specific reasons, but I mean, it would be great to make this work without all these tools. And if it's accomplished, if it works and it's generally available, this is perfect. And we don't have to go further with reasoners.
So I'm not the thrust of the design of FHIR is to delegate all of that logic down to the terminology server. So I got a way to express the logic I want. I've got a terminology server that can do it, and I can integrate that into my EHR server and search a whole bunch of pure EHR stuff and pull in the reasoning down from under the terminology server. And I don't need to do any data extraction and loading into a reasoner because all of the knowledge that you're looking for is packaged inside the terminology server. So I feel as though it would be a lot more deployable for everybody if we could get that logic that you're chasing packaged inside the terminology servers, so it's modularized and reusable broadly.
So we went through that exercise, and unfortunately the specification was difficult to read. But we went through how one would invoke a generic reasoner through a terminology server.
So
proceed with that.
that is not, the terminology service API is code system based, not reasoner based. So you have to sort of add the reasoner to on the code system based.
The CTS2 was based on presence and the possibility of an L reasoner behind it. So the question was, if I give you this additional set of facts, what conclusions can you draw, which is the abstraction of the utilities. If I tell you this, what more can you tell me knowing what you know?
Maybe we should do something around this in the terminology tracking you will learn.
Yeah.
To try and sort of tease out this, because certainly the modularity, the way FHIR is designed, this stuff should all be down in the terminology servers and you can easily available. But perhaps the interface language is not yet strong enough.
So,
That may be.
But perhaps
why not then try to get in the FHIR terminology service and accepting all files and the reasoning behind it? Because then you can leverage from
Well,
FHIR program
kind of.
all the different ontologies and reasoning behind it.
kind of that's what I'm thinking.
Yeah.
But for us, it's all, we don't care about how the terminology service work, right?
Right.
We just say, here's the API. But the connector thing would say to everybody, well, here's an L file you should be able to handle to deploy. What's the language of the API? And then everybody figures out how to make that happen. But it seems, rather than have to go through that process, although the other thing to say is that for all that I'm saying, there's things you want to be able to do in the process I'm laying out. And so some of the stuff you're doing is just about to do. But I would like to see, as much as possible, packaged into the terminology service space.
And I'd definitely be interested in pursuing that with you. I think we need a blackboard and
Are you going to be in New Orleans in January?
I'm turning to my keeper of funds.
Oh, no, yes, clearly you would be. I didn't know that. That's really good. So I think it'd be good if we can push on this.